Hello students, today in this video we'll solve an ordinary differential equation here. So here the given problem is d square plus 2d plus 1 into y equal to e power minus x. So let us write the given problem now. Let d square plus 2d plus 1 into y equal to e power minus x. Since this equation is a non-homogeneous equation, why do we say non-homogeneous equation? Because the equation is equal to some value, right? If it is equal to 0, then the equation will be a homogeneous equation. If the equation is equal to some value, then the equation is said to be a non-homogeneous equation. So this is a non-homogeneous equation. Therefore, the solution of the given differential equation is we'll get y is equal to complementary function plus particular integral. So for this equation, the solution will be y equal to complementary function plus particular integral. So first we'll find the value of complementary function. So to find the value of complementary function, let us assume the given equation equal to 0. So let us write d square plus 2d plus 1 into y is equal to 0. Now we need to write the auxiliary equation of the given equation. The auxiliary equation is we need to take only the d terms. We should not write y in the auxiliary equation. You need to take only the d terms and you need to replace it as m. So if we replace it as m, we get m square plus 2m plus 1 is equal to 0. Now you can see that this equation is a quadratic equation. So since this is a quadratic equation, we need to find the root. Here you can see the coefficient of m square is 1. So you need to multiply 1 and a constant term. So the coefficient of m square and the constant. So here the coefficient is 1. So 1 into 1 is 1. So you need to multiply two terms such that the multiplication should give you 1 and the addition should give you 2. You can take 1 and 1. If you take 1 and 1, the 1 into 1 is 1. Okay, correct. And if you add 1 plus 1, it is 2. Yeah, this is also correct. Therefore, this is the root. So, this equation can be written as we got the roots are 1, as we got these values here. So, I'll replace this equation as m plus 1 into m plus 1 equal to 0. Why I am writing 1 and 1? Here the values are 1 and 1, right? So, I'll write m plus 1 into m plus 1 equal to 0. If I take plus 1 to that side, it is minus 1. So, the value of m will be minus 1 comma minus 1. As you can see here, the roots are real and equal. So, if the roots are real and equal, then the complementary function is y is equal to ax plus b into e power minus x. So this is my complementary function. So now alhamdulillah we have find the value of the complementary function. Now we need to find the value of the particular integral. So next I am going to find the value of the particular integral. So I'll write the heading particular integral. So to find the value of the particular integral, we write pi is equal to, pi is nothing but particular integral. So pi is nothing but, you need to take the question now. So particular integral is 1 divided by, you need to write only the terms of d here in the denominator. So it is d square plus 2d plus 1 into e power minus x. In RHS it is given e power minus x. No. So using e power minus x, you need to find the particular integral value. So I have written e power minus x. So this equation is equal to 1 divided by. So this comes under type 1. Type 1 is nothing but, type 1 is e power ax. So the e power ax, if we get e power ax, it means it is comes under type 1. So if it comes under type 1, we'll replace d equal to a. So this, as you can see, this problem comes under type 1. Here you can see the value of a is minus 1. So for this problem, we'll replace d equal to minus 1 now. So if you replace d equal to minus 1 now, then the equation will become d square. So d value is minus 1. So minus 1 the whole square plus 2 into d is minus 1. Minus 1 plus 1 into e power minus x. So this is equal to 1 divided by minus 1 the whole square is 1. 2 into 1 is 2. So we have plus and minus. Plus into minus is minus. Plus 1 into e power minus x. 1 minus 2 plus 1 is nothing but 0. So in the denominator we are getting 0. So if in the denominator we get 0, we'll apply case of failure. So now we are going to apply the case of failure. My case of failure is nothing but, so in case of failure, what I'm going to do is, you need to assume the given problem now in the particular integral. In the particular integral, what we need to do is multiply the numerator by x and differentiate the denominator. If the denominator is d square plus 2d plus 1. If we differentiate the denominator, we will get 2d plus 2. The differentiation of d square is 2d. The differentiation of 2d is 2. Balance, here we get e power minus x. This term I'll write it as it is. So now again, as you can see here in the denominator we have d term. Then we are going to replace d equal to, the coefficient of x is minus 1. So we are going to replace d equal to minus 1 now. So if we replace d equal to minus 1, we get x divided by 2 into, in place of d I'll put minus 1 plus 2 into e power minus x. So this is equal to x divided by 2 into minus 1 is minus 2. Balance, we have plus 2 e power minus x. So this is x divided by 0 e power minus x. So again, as you can see here, the denominator becomes 0. So here for the first time we applied the method of failure. Again, after applying the method of failure, again in the denominator we are getting the value to be 0. So again we will apply the case of failure now. So second time we are going to apply the case of failure. Again applying case of failure, we get, so this is my particular integral which I got known. So particular integral is equal to the same procedure. So in this equation we need to apply the same procedure. The procedure is multiply the numerator by x and differentiate the denominator. Okay, already in the numerator we have x. So since we are again applying the case of failure, again we'll multiply the numerator by x. Already we have x here. So x into x will become x square divided by, now if I differentiate the denominator, it is 2. So differentiation of 2d is 2. The differentiation of 2 is 0. So plus 0 e power minus x. So this is x squared by 2 e power minus 2x. Here we are getting some value here, right? So this completes the proof. Therefore my particular integral is x squared by 2 e power minus 2x. So this is my particular integral. Hence the solution is, y is equal to complementary function plus particular integral. So y is equal to, my complementary function is, as I have found before, ax plus b e power minus x. So this is my complementary function which I got before, right? I'll write it. Okay, so this is my complementary function plus the particular integral value which just now I obtained, x squared by 2 e power minus 2x. So I'll write it, x squared by 2 e power minus 2x. So this is my final answer. So the solution is y equal to ax plus b into e power minus x plus x squared by 2 into e power minus 2x. Thank you.